So this problem asks us to go and model a situation. For example, a firework, a ball, a long jumper, anything that can be traveling across a screen, across a moat, across a pit. And what we have to do here is we're just going to read the question. And the first thing we got to do is we have to create a diagram of what's happening so that we can come up with our own equation for our parabola. Now there's 2 or 3 different ways, but we'll go over them while we're doing this problem. Okay, so a fireworks display has a fireworks that's launched from a height of, well, let's underline the important things here. We got a 2-meter height, and along with that 2-meter height, it's launched from a height of 2 meters above the ground, and reaches a maximum height 40 meters at 40 meters at a horizontal distance of 10 meters. So I think what we'll do is we'll plan our graph, our situation accordingly. So right now I have a graph that kind of looks like this. This is the horizontal distance. Horizontal. And what I'm going to do is I'm going to call this the x value. And this, the up and down portion of our parabola, this part here, we're going to call our height. And our height is going to be y. And I can't even write the word y. The letter y. Oh boy. And since we have our y value, it says here, we start with our first problem here. So I'm going to highlight that real quick and kind of give us an idea of what this is about. It says at 2 meters above the ground. It starts at 2 meters above the ground. So basically, that kind of represents the Y-intercept on our problem set here. So I've highlighted where I want it, and that's where my point is. Now, if I was looking at that point, I would graph my point as 0, 2. Now, let's go and put the maximum where that occurs. So it says for our maximum height, occurs 40 meters above the ground, and there's a horizontal distance of 10 meters from the start. So technically what's happening here is we go from here all the way out here, and this is 10 meters. And then directly above the 10 meters here is where our maximum is going to be. So if I was looking at this from here to here, this is 40. So the y value of our vertex is 40. And given the fact that our y value is 40, the x value that makes that happen is going to be the axis of symmetry, but it's just the distance x, the distance we traveled along the x-axis here from position 0 all the way to 10, 0, and up here. So this is 40, 10 actually. So our vertex for our parabola, which I'm going to draw a nice little parabola here, kind of looks like this. Now, just like before, see this other point over here? Because of the axis of symmetry, if this is 10, that means this from here to here is 10. So that means this point is 20, 0. Now, let's see how we could do this. If we're doing this graph, its problem has asked us to draw. We had to draw it, and then once we drew it, we had to come up with a basic equation. So remember, if we have something in vertex form, we always start with y is equal to a x minus h squared plus k. Now, because we have our vertex clearly labeled, we can use that as the point, remember, h and k in our basic equation. So remember, our vertex is always hk. So we can rewrite this equation as y is equal to a times x minus 10 squared plus 40. Now that I've got that basic equation, what I have to do is I have to take what I know as one of the points that we're going to use in here, and I'm going to make a correction here. This is supposed to be, this point here is supposed to be 22. So now we're going to take either 22 or 02, one of those 2 points that we have here. So that's either this one or this one, and plug that into this value as the x and y of our parabola. So when we plug that in, we're going to get the following. I'm going to use 22. You could have used 02. I don't care. It doesn't matter. So I'm going to use 22 in this case because it really doesn't matter which point I use as long as I got my points right. So now this is 2 equals a 20 minus 10 squared plus 40. And now, once we've got that, we simplify. So this is 2a times 10 squared plus 40. 10 squared is 100, so this value here turns into 100a, and then we just bring the rest of that work down. Now that I've got that last line, we have to solve for a. Bring the 40 to the other side, and we're going to get 2 minus 40 equals 100a. 2 minus 40 is negative 38, is 100a. Now we divide both sides by 100, and we can use the a value here to 2 decimal places. So a is going to be negative 0.38. Once I've got that, what you need to do is you need to restate the equation. And we'll do that right now. And so we say, the equation is y is equal to, we take whatever we have for our a value, and what we're going to do is we're going to take a moment and we're going to plug that back in to the original equation that has the a. So we've got y is equal to negative 0.38 x minus 10 squared plus 40. So for B, it says the firework continues to travel an additional 1 meter horizontally after it reaches its maximum. Okay. What was its height? What was its height when it exploded? So if I look at the graph, it says the height, it travels another 1 meter to the right of the maximum. So this is going to be 11 and some number. I'm going to put a question mark there. So what we have to do is we have to take our basic equation and we're going to plug in x equals 11 and we're going to see what our value is. And now I'm just going to quickly draw what we had before. 22. Remember the distance traveled between here and here is 10. So it's 10, so it's also 2. So we substitute this into our equation. So we go, if our original equation is, if I have x is equal to 11, then y is equal to negative 0.38. And we substitute x is 11. So we get 11 minus 10 squared plus 40. And you get negative 0.38 times 1 squared plus 40. So that's y. And y is equal to negative 0.38. 1 squared is 1. So 1 times 0.38 is 0.38. And we got plus 40, which means our final height, y, is 39.62 meters. Now, the last part of this problem is to figure out when the parabola hits the ground. And I'm going to show you how to do that with some skill. Now, this skill you've possibly seen before, but we're going to use the fact that our parabola has 2 possible points on either side of our parabola, just like how we had for part C. It says part C is what's the horizontal distance, this horizontal distance when it hits 2 meters. Again, we know it's 20. I'm not going to do that. We're going to do this last bit. So just like I said for C, take a look at the picture that we had above. We found that the horizontal distance to the next height, which being 2, is 20 meters. So here's what we're going to do. For part C, we're asked to find. Now, when we're asking for when the height or when it hits the ground, if something hits the ground, we say our height equals 0. So in this case, in that case, y is equal to 0. So let's go and do some calculations. It's going to take a little bit of time, but you're going to see how this works. Start with your basic equation. Now that you've got your basic equation here, we let y equal 0. So y is equal to 0. So you get negative 0.38 x minus 10 squared plus 40. And once we've got that set up nicely, the key is to use SAMDEB, because we have to do, in order to find x, we have to undo all the subtraction first and then all the division and multiplication, and then we're good to go. So the first thing that we're going to do is fix this. And what we're going to do is we're going to take this 40 and we're going to move it over to the right side of this equation. So if it's positive 40 here, it becomes negative 40. So we have negative 40 is equal to negative 0.38 x minus 10 squared. Now, since I have that, what we have to do is we have to take a moment and divide both sides by negative 0.38. And the reason why we're doing that is because it's the last multiplication outside the bracket. And I'm only going to about 3 decimal places, and then we're going to end in 2. So in this case, you're going to have, on the left side of the equation, you're going to have 105.236. And that's equal to x minus 10 all squared. Now think of BEDMAS and think of BEDMAS and SAMDEB. So SAMDEB is the last thing. So we have to get rid of the bracket, but if there's an exponent, we got to do that first. So what we have to do, if we have something that's squared, in order to get rid of the square, we square root both sides. And we end up with this x minus 10 is equal to the square root of 105.236, and that turns out to be 10.26. Now, I'm going to tell you something very important. When you square root something, we have a plus and a minus for this. And the reason for that is because of our parabola. Think of this value that we have here as the distance to the left and to the right of the parabola, right? How much we have to add to the distance to the right of the axis of symmetry. So you know that for every point on a parabola, say except for the vertex, there's always a matching point on the other axis, on the other side of the line of symmetry. So we're going to have to add 10.26 to some number and subtract 10.26 from some number. So in this case, we've got x minus 10 on this left side here. And what we're going to do is we're going to take this 10, this minus 10, and we're going to move it over in front of this plus sign here. So we end up with the following answer. X is equal to 10 plus or minus 10.26. Now, this yields 2 answers. Answer 1 and answer 2. So for answer 1, we've got x is equal to 10.26 we have 2 possible answers for this solution. Because it says 10 plus or minus 10.26, that means x is equal to 10 plus 10.26, which is 20.26. Or we have x is equal to 10 minus 10.26, which is equal to negative 0.26. Now, when you look at these 2 solutions, right, it's telling me that the first one is telling me that the point that we're looking at here is right here. So when our y value is 0, we have 20.26 being the x value. Now for this second one, that one is a valid answer. So this one should be our answer. Now if we look at the other answer here, it says x is negative 0.26. But didn't we say that the height of the fireworks started at 2 meters? So you can't possibly go back in distance, because if it starts there, it's kind of like you're going back in time, and we can't do that in this case. Sometimes you can, sometimes you can't. This time you cannot. So this value here we say is inadmissible. And so we'd say, so the ball hits, the firework hits the ground, at 20.26 meters horizontally. And that's it. Our answer is done. Now what I want you to do is do the practice problems that I gave you. There is a question just like this there for you to do. Good luck. Wait, sorry. I should remind you how to do this one more time. So when we're looking for something that hits the ground, we have to remember that the height is equal to 0. You have to take your original equation that we started with, that we calculated, and then we let y equals 0 in our equation. We solve for this by using SAMDEB and going backwards. So I take the 40, move it over to the other side. Then I divide both sides by the a value. Then after that, I square root both sides. But when I square root it, it's kind of telling me that there's either a number just before the axis of symmetry or after. So that's why we get the plus or minus 10.26. Then we take the negative 10 that's on the left side, the right side, and move it over to the left, and we get 10 plus or minus that. So then we split the two possibilities, and we evaluate the answers for both. Sometimes one value is inadmissible, and that's it. So we just basically state our final answer based on the one value that works. Okay, and we're done.